Good afternoon, at least in Europe, everybody. Thank you for your time in joining us on details on the Embedded Academy. We will first have a short introduction and then go into the e-learning. But first of all, I would like to introduce myself. My name is Annette Kempf. I'm the CEO and founder of Eclipseina, and I initiated the Embedded Academy because I believe that you have to learn continuously during your work life to be able to develop state-of-the-art products for your customers. So now we look into the Embedded Academy. This is just the intro slide. The Embedded Academy provides competencies needed for electronics, electrical engineering, e-mobility, embedded system and software development. And this Embedded Academy we have because we want you to be successful in your product development, and we want to support you as best as possible from our side. Short view on Eclipseina. Who are we? Where are we coming from? Eclipseina was founded 13 years ago, and we've been supporting ever since the engineering development in the embedded domain by classroom trainings, consulting, and our products, which we see there on the slide below. So the products are, for example, the Embedded C software library. It's a lot in the area of charging. So we have a charge controller for charging stations, which is the intelligence of charging stations, and also charging test systems, which are doing the testing of the charging communication. And this is completed by what we are looking now at, the Embedded Academy with still the classroom trainings and so on, but very strong focus on e-learning. All this learning field, we have 4 main areas. Our goal is to support onboarding and transformation, support you as a customer. So support new strategies and technical roadmaps, which are driving the training and personnel development of the engineering staff. And we do this by consulting, by presence and in-house training, the online training, videos and e-learning, where we look into more detail, and the development of, for example, confidential training material, which only the customers then are using. I would like to go through this general stuff real fast. We also have trainings like classroom and as in-house trainings. And then we'll have a short look at the portfolio. As we do most of the trainings in Regensburg, where we are located, the most of the trainings are in German, so the portfolio in terms of English is not so huge. Here, for example, this is how it looks with the training dates. Just as an example, which you can find on the website. So you find all the trainings, and in the first column, it's indicated whether it's German or English. And then you have the dates and also the weekdays with these 7 days where it's marked which days it is. Which trainings do we offer? We offer software architecture, which I consider as very, very important. So this is something we even sent the trainer outside of Europe already. And I think this was very wise to do this. For our customer to train their personnel on software architecture. And of course, we have some other things which are going more in detail, like C, C++, or our embedded Linux. We also provide one training, which might be interesting because this is an online training, which is also taking place quite soon. It's Certified Tester Foundation level. We have collaboration with a company which has expert know-how on RISC-V and all the software tools and handling around this. And also measurement technology we provide as a classroom training. But we see now that we published the first e-learnings in this direction, that the demand is decreasing, and we will do a lot more in terms of e-learning there. So most likely this classroom training will not exist much longer. For charging, we are the experts because we are not only doing training but also charging. And so for the charging trainings, I think this is really interesting because it's going into detail, and especially some hardware topics. This training on power spectral density calibration of PLC modems. There you have very expensive devices which you need to use. So this is necessary to have it as a classroom training, and this cannot be replaced. Now we're coming to the real subject, the e-learning portfolio. The e-learning portfolio, the first letter is A, so automotive is on the page at the beginning, but it's not the only topic we're working on. So we have automotive cybersecurity, and we have automotive spies broken down into the different areas so that it's possible to maybe not do all the trainings, but to say, okay, I'm for example, I'm in engineering, so I do the automotive spies overview, I do the engineering training, and I also do the supporting processes, but the rest I don't need, and others might not need the engineering trainings in detail. So this is the automotive page. Yeah. I will share also the view directly into the e-learnings. This is just to have a few of these pages. One major field then is also e-mobility. So if you are in automotive e-mobility, then the match is perfect. Then you can have a study time of 5 weeks to do everything, and it's all useful for your work area. For e-mobility, it's a general training, and for e-mobility we have covered both. So it's the infrastructure side with e-mobility and electric charging. I see I used the German page here. So we have in German or in English, but the screenshot is the German one. So we have e-mobility and electric charging. And especially if you're on the vehicle side, then for the vehicle, you need the e-mobility to understand how e-mobility is working. You have electric charging, and you have an electrified powertrain, which includes the hardware, meaning the inverter, the electrical machine, the control of the electrical machine, all the control algorithms, the battery, and the battery management system. Yeah, and within the e-mobility training, we put in the system view. And if you are in the vehicle, it's also important to work on reducing the noise. Yeah, so you have also training on noise, vibration, and harshness, in short NVH. Because the deep sound of a combustion engine is okay to the ear, but if the electric motor is doing this more higher noise, this kind of hurts even if it's not so loud. Yeah. But this kind of noise you simply don't like. So this is an important topic there too. And vector control is one part of control algorithms you need with vector transformation for electrical machines. So this is for e-mobility, the portfolio. Then we have in software, we still have a little bit more on automotive. We have automotive bus systems. For others which are non-automotive, important to know, we started with automotive bus systems, and currently we almost finished. We'll release soon. We have all the basic terms you need for bus systems, like what is a parity bit and what is CRC checksum, what is a clock, and so on. These things, and also the ISO-OSI model. This will be released soon, and then we'll continue on working on different bus systems like Ethernet, CAN NFD, and so on. This will be coming up soon. We have AUTOSAR, which is an automotive standard mainly used in the basic software. We have embedded software basics. People who have really experience say it's very basic, but it's good if you have new colleagues that they know the very basics, like fixed point, floating point, and which errors you can have and how to handle this. What I consider as least as important as architecture is operating system and real-time operating system, that you understand how the operating system is working, and for real-time operating system, the different scheduling mechanisms, and how are tasks working, because especially now in the past, it was not that much important when you had a single core system, but now with multi-core, it's getting more and more important to understand the scheduling and how the different cores are working. We have automotive cybersecurity, but we also have trainings on cryptography, which is quite extensive, where you have more or less all encryption methods which are used right now in the field inside one training. It's something I really like, because it's okay, it's mathematics, yes, but even if you didn't have to do anything with IT cybersecurity before, you can understand the content of this cryptography training. And then we have more these classical things coming from electrical engineering. Something which I consider also very important for if you are working in the embedded domain, and if you are not coming from an electronics and electrical engineering studies, is to have electronics and electrical fundamentals, to know the things in electronics you need to understand the hardware, how it's behaving, it's part of the control algorithm, for example. And then we have, in addition to the electrified powertrain, we go into more detail in the electrical machines and control of electrical machines trainings. And with strain gauges, we opened a new field, which means it's measurement technology using strain gauges. And there we released the first parts, but there's also a lot of work ongoing. There will be new releases soon. So this is like the general view through it. And this is more or less the motto we have: the world is changing. Is your engineering team ready? From my side, I have to look at a different monitor now. So my face will disappear, and you will have more possibilities to look into the technical things. If you want to have a sneak peek into a certain e-learning, to say, yeah, but can we have a look there? Please write in the chat. And this will be now very hands-on. So I'll just go through and show you the pages, and I will leave the presentation now. Yeah. And I will share my screen. Looking at the right one. So Now you will see my screen. It's oh, I need to do something more, so I will stop again. Yeah. So now see my screen again. It's the right one. So this is the portfolio page. So here, what you saw now in the PowerPoint, you will also see here as the portfolio page. And then you can click on certain e-learnings. And as you can see, for example, we also did one which is just in German. We'll of course translate soon. Yeah. And I prepared some of the pages already. So this is looking into the EV charging, and there the example is the EV charging with a pilot signal. So for EV charging, you have a possibility to have the more sophisticated communication, I would call it, which you need for DC charging, but you have also the basic communication, the so-called low-level communication with the pilot signal, which you need always, also for the simple wall boxes. And so I chose this. It's just getting to give you some examples and to give you the chance to have a short sneak peek into it. So for e-mobility, we use the color yellow for everything. So it's the same type of content, has the same type of color. And I will just go through and show you how it looks like right now. Yeah.
Pilot signal is a mandatory part of EV charging. It provides a very restricted way of communication between the vehicle and the EV charging station by using a PWM signal. The EV charging station communicates the available predetermined charging current via the duty cycle of a 1 kHz PWM signal, while the vehicle communicates by varying the voltage level of the state of charge. The pilot signal forms the basis for any kind of signal link between vehicle and EV charging station.
I think I have to make it a little bit louder. No? Okay. So this is an example, and for the example, you saw that you hear the speaker text and that you see the animation. And if you look at the animation in the beginning, yeah, you have nothing there.
Pilot signal is a mandatory part of EV charging. It provides a very restricted way of communicating.
And then we enter putting the charging station and the vehicle, and they have the vehicle has now the color yellow. Yeah.
Between the vehicle and the EV charging station by using a PWM signal.
Then we do the connection.
The charging station communicates the available predetermined charging current via the duty cycle of a 1 kHz PWM signal, while the vehicle communicates by varying the voltage level of the state of charge. The pilot signal forms.
And then we have like the state of charge, and when it starts charging, it's like shown with green to say, okay, now it's charged, and green you can go. And you see also a constant animation of the current and the state of charge. Yeah. Which is depending on the state of charge, you have a different level on the high pulse of this PWM signal. So this is, for example, an example how we are presenting this. It's a general introduction, yeah, and then I will jump to the next one where you see the schematic, yeah.
Let us now have a look at different us now have a look at different.
So this is the schematic on the charging station and vehicle side for this very primitive signal, yeah. And then here it's explained step by step how it's connected and how the level is changing. I admit it's quite a lot of information because it's from a content point of view, it's rather basic, but nevertheless, it's quite full and you need some time to adjust and see everything. Yeah.
Let us now have a look at different charging states. In state A, the vehicle and the EV charging station are not yet connected. The oscillator with the 1 kHz PWM signal can still be deactivated. The power outlet is disconnected from the EV charging station. At the control pilot, a voltage of 12 volts is applied at resistor R1.
So now you see it. You have, as there's no connection, the power is this 12 volt. Yeah, here. And you see that the charging station and the vehicle, like the speaker text said, they are not yet connected. Yeah. If you click on here, this is also some information you always have. This is how the trainings are designed. Then you get the explanation what you need to do. I do this now.
Click next on the button Connect Vehicle with Charging Station. If you click on the yellow symbol, you get an overview on the defined vehicle status via EC61851.
So now I only do the first part, yeah? Connect vehicle with charging station. So
the vehicle connects the resistor R2, which causes the voltage to drop from 12 volt to 9 volt. The EV charging station reacts by establishing a connection with the vehicle. Switch S2 is still open. The car communicates the state of charge via the voltage level. In state B, the oscillator is turned on by the PWM signal. As soon as the vehicle has recognized the PWM signal, another resistor is added and it automatically changes to state C. In reality, it is a smooth transition from state B to state C. This manual transition from B to C, as shown here, does not exist in reality, and was only shown this way in this learning unit for the sake of clarity.
So, like it said, now this we now by connecting we switch to state B, and usually it's going like to the next step immediately. But we needed to show in the picture what the status is, and you see in the animation that now it's connected via the connector, and then you have also the connection in the circuit. And by connecting it, we already got the feedback that our schematic is wrong because it's minus 12 plus 9. But this is correct because you have a diode in here. And the oscillating current going back is not possible. Only in one direction is possible due to this. And this means you have a resistor, and there you are in this resistor you lose these 3 volt, and this is why the voltage level is going down. And this information then gives information on the charging stage. So I don't want to teach you the charging, but this is one representation we did, and just one example on the making of the e-learnings. Yeah? And then the next one I want to switch to is CENT bus protocol. As CENT is kind of strange in comparison to normal bus protocols, because this it's really a measurement according to time and not by clock information. And this is why I switched now to the example here with the measure time, because you have here the protocol with the different parts, and you have synchronization. And synchronization means really, in this case, measuring time. you have then the information on status, communication, and so on, and you are transferring data nibbles. Yeah, so just for bit. And if you want to see how data nibble is defined, we have quite a nice glossary unit on data nibble. And it's some fancy background know-how also, which I liked more in terms of language. So even people who are very, very aware and knowledgeable about this field, there's still some nice little things you can learn. And now I want to show you how this means, what's shown here. First of all, the general explanation, then again the information button, and then we'll measure. Yeah.
For a better understanding of how the coding and the decoding of the send protocol works, let's look at a numeric example. Because the duration of the pulses defines their data values, we first measure the time of the different pulses. Click on the stopwatch to measure the time for the different pulses.
So we have to click on the stopwatch. We here is saying the same to measure the time.
For the synchronization pulse, we get 168 microseconds. For the status and communication pulse, we measure 36 microseconds. Now we have a series of 6 data nibbles. The first data nibble has a duration of 81 microseconds. The second data nibble lasts 51 microseconds. For the third data nibble, we get 66 microseconds. Data nibble number 4 has a duration of 42 microseconds. The fifth data nibble is 60 microseconds. And finally, for the sixth data nibble, we measure 36 microseconds. This is followed by the CRC checksum. For this, we get a value of 63 microseconds.
So it's really measuring the time, which is strange if you worked with SPI, CAN, and others, but it's really the concept behind, yeah. And then
now we have to convert our measured values from micro.
And now here is the conversion to the ticks. So this is the next part, yeah, where we see the calculation, yeah.
Seconds to ticks. The duration of the synchronization pulse is defined in the specification of the send data protocol. According to this specification, the value must always be 56 ticks. As we have already learned, the synchronization pulse is the benchmark for the evaluation of the other pulses. It specifies how many microseconds a tick lasts. In the previous slide, we measured 168 microseconds for the synchronization pulse. So we have to divide these 168 microseconds by the 56 ticks. This gives us the time per tick, which we will use as a unit in the following. In our case, it is 3 microseconds. To convert the other values into ticks as well, we have to divide them by the 3 microseconds. Click on the yellow arrows to get the results. The 36 microseconds of the status and communication pulse divided by 3 microseconds gives 12 ticks.
So I think this is enough on send, yeah, to show you how this is done. The next example is something non-automotive, yeah. It's all these encryption things, and I would then show some encryption and decryption, which is less complicated than the enhanced ones. So we are looking at the historic part at SkyTail.
Equipment for this encryption method was a strip of parchment or leather on which the message was written down, as well as a wooden cylinder. The recipient needed to have a cylinder of the same diameter. The first step was to wrap the parchment around the cylinder. Now, we can write down the message. We decide to mention our meeting at the lake. The message is now written from the left to the right over the edges of the strip. Thereby, we write on the whole strip and, if necessary, add arbitrary letters to fill the space. Afterwards, we only send the parchment. For the recipient to correctly decrypt the message, he needed a wooden cylinder of the same diameter as the one used for encryption. Without knowledge of the diameter, there was only the chance to try arbitrary cylinders of different diameters. If a cylinder of the wrong diameter was used, the message remained unreadable nonsense. This equals the use of the wrong key in the decryption process.
So this is a very basic example. What I like here is that we really started with a classical cryptography because it's very easy examples to get onto the topic. And then we have all the modern cryptography methods or encryption and decryption methods. This was just a short sneak peek into encryption. So this is a software topic. Then we have the topic of in general electronics and electrical fundamentals. This is, I think, also a very, very important area many people are using on a regular basis. Yeah. So this is an example here.
Complex numbers is very useful to describe alternating current and voltage. On the right you see the sine curve of alternating voltage in blue and the sine curve of alternating current in yellow. On the left you see the vector representation of the two curves at the point 0 in time. The current has a phase shift of 90 degrees compared to the voltage. This phase shift is also visible in the vector representation. Now we take a closer look at the current. The complex current can be written in the same way as any other complex number. Now we introduce the angular frequency, which indicates how fast the angle alpha is changing. During one period it changes over 2π. Remember that the period is the inverse of the frequency. So now we can express alpha as the product of the angular frequency and the time and add the phase shift phi. This term we can insert into the function for the complex current. We can distinguish between the real and the imaginary part. This is also visible in the vector representation.
There's a lot more. You see, there's a lot more of input or information on all the different things you need to know. So there's also an introduction on complex numbers and so on. This was just like showing, okay, you can just put a formula, how the professors are usually doing it, or you can draw a signal and show in a schematic the vectors and so on. And you can use colors. It doesn't have to be all black and white. You can use a color to say, okay, I know this is the real part and this is the complex part. So I have there the J in, and I have here the imaginary axis, and then I will get the vector, which is the addition out of real and imaginary. And I think it helps to see the things, how they are, and to work with colors and so on, because this is giving you a chance to connect the stuff easier and to memorize it easier. So here, I must say I was quite late, so I didn't find the place I wanted to show you, because we have these different scheduling algorithms. So maybe I need to look into taskban again, but we can have like a short look at also priority scheduling.
With priority scheduling, an algorithm examines which task has the highest priority and allocates CPU time and other resources to it. A priority is just a reflection of the relative urgency of a task. There are many policies that you can use to assign priorities to tasks.
So there are different scheduling classes and methods behind, but I wanted to look into something where you really see the tasks.
First, we want to repeat the different states a task could adopt in static scheduling. If you want to repeat the difference between static and dynamic...
So this is because in this case, it's real-time operating system training, and then some of the content from the operating system training is repeated here to have a short revision to still memorize what you learned in the other training to get the right access to this topic.
Repeat the different states a task could adopt in static scheduling. If you want to repeat the difference between static and dynamic scheduling, click on the yellow button in the lower right corner. Note that the following information is exemplary. The states as well as the transitions depend on the operating system you use. Let's start with the task that is running. This is the task that is assigned to the CPU at that moment. From running, it can be preempted to be ready and then start again to running. When preempting a task, the scheduler decides to interrupt this task and start another one. If a task cannot be executed anymore, it has to wait. This can be the case if a task needs a value from an input device, like a sensor. After that, it can be released to be ready. If a task is finished, it terminates to the state suspended. From this state, it can be activated to be ready again.
So, and here there is more on preemption. Why is preemption so important? I don't know how much lifetime I spent to find errors because people didn't know how preemption is working. Because then they've been overwriting global variables, which of course you shouldn't have. But for me, it has been very important that everybody knows what preemption is.
On this slide, we want to repeat preemption. Preemption means that a task interrupts another task with a lower priority. Let's assume one task is activated while another one with a lower priority is running. There are 3 different types of tasks that handle this situation differently. The first category are the non-preemptive tasks. Those cannot be interrupted by higher prioritized tasks. So the second task has to wait in the state ready until the first task has finished. Then there are cooperative tasks. Those can interrupt a low priority task, but only at dedicated schedule points. And the third category are preemptive tasks, which can interrupt low priority tasks at any point. Now we take a look at 3 examples. Therefore, we draw a diagram with time as the x-axis and the priority as the y-axis. The first example covers the non-preemptive tasks. The lightning marks the activation of the first task. Then we see the task being processed over a period of time. During that time, a higher prioritized task is activated, but this one has to wait in the state ready until the first one is finished. Then it can also be processed. We take the same example for the cooperative tasks. This time, the second task only has to wait until the next schedule point is reached. Then it can change from ready to running. When it is finished, the first task continues. In our last example, the preemptive task is interrupted as soon as the second task is activated. So the second task doesn't wait at all in the state ready.
Okay, there's a lot more. And I think the operating system basic know-how is very, very important. Then I would like to go to next to the topic of strain gauges, which we also implemented, and they are just on like the intro part, which is also part of the e-learnings. So we really start with the motivation and the beginning.
Strain gauges. It is important to understand how to install and use them. In addition, one must be able to evaluate and interpret the measurement results correctly. Otherwise, the results will be worthless or, in the worst case, incorrect. Since there are many mistakes that can be made when using strain gauges, it is essential to read up on the subject in detail beforehand. The subject is so important that the VDI, a German engineer association, has drawn up Standard 2636, which defines what content should be taught during the training of technical personnel. The personnel will then be able to correctly plan, perform, and evaluate measurements with electrical strain gauges. Before we begin, we should clarify the question of what a strain gauge is in the first place. An electric strain gauge is a sensor that measures the strain of the material. For this purpose, the change in resistance of an electrical wire is used. Now we will take a look at the physical principles underlying measurements with an electric strain gauge. We start with the material that is being tested. A load, this can be a force, for example, acts on this material. This load leads to a tension within the material. In case the material is elastic, we then can also observe a strain. In order to be able to measure this strain, there must be a firm connection between the material and the sensor. This is the only way to ensure that the sensor stretches exactly like the material. The strain of the sensor leads to a change in resistance of the wire, and this resistance change is then measured and evaluated. From the measurement result, the strain and tension can be calculated, as well as the load that has had impact on the material.
Okay, so I would go now back. What would be interesting for me is to get some feedback. We would like to have a sneak peek into this, a sneak peek into that, but then I would, for now, stop the screen presentation, and get back to you. I don't know if there are questions, if there are wishes to say, I would like to see this or that. As I said, we have content which is representing more than 6 weeks of classroom training. Of course, there is a lot of content, and I also don't know all of the content. Some of the things I've been reviewing quite a long time ago. This doesn't mean that I can navigate through everything, but we could do this together and say, we would like to look into this or that. This would be not a problem at all. Any questions? If not, then I would like to close. And if you have questions later on, not now, but maybe to a later time, and say, yes, now I looked at this again, I would like to know, or I would like to have an introduction on what is additionally to do. Maybe what I can show you, I will share again, sorry. What I can show you is where you can find the content for each training. If you look here at the web page, and to say, okay, what's inside? What do I learn, for example, in electrified powertrain? What's the content there? And the content description is for all of the trainings, it's the same. So we have in the beginning a very short part where you have a content and where it's described this is the content and how much time it takes and what are the chapters inside. It's very, very short, yeah, but you get an overview. Okay, the electrified powertrain has 4 e-learnings inside, and these 4 e-learnings are power electronics, electrical machine basics, control of electrical machines, and battery management systems. And these are composed of different parts, so you know roughly what's inside. Then we always have a target. So what do I learn from this? Yeah, who should learn what I learned from this? Then we have the trailers. This might be interesting. They are all on YouTube. So on YouTube, there's a playlist. Maybe we can provide this in the chat, a playlist with all the trailers. And then each trailer is just 1 minute. So within 10 minutes, you get a rough insight into 10 different topics, what to expect. And then also we provide the insights. And the insights are pictures from the e-learnings, which give you a picture of, aha, this is inside. For example, torque over speed as an explanation. Why are rotating field machines? Why are you using them? What are they for in a table? Or here, like general principle, water circuit example. No? And then here, for example, what is a half bridge? So these are the insights to have a connection on what to expect and how is the making of, similar to what I've shown before. The course content, this is really also given by the underlying learning management system we have behind. And it's more or less the same what you saw in the text above. So these are the different units. So you have one unit with introduction, you have basics of power electronics, then you have a quiz. Then you have the components of power electronics and a quiz. Half bridge, quiz. Thermal design and assembly, and quiz. This is the course content with its chapters. And what we also provide for every course is kind of like standard pattern of questions and answers. So what is an electrified powertrain? Why is it needed? How is an electrified powertrain related to embedded systems? And what do I learn from about electrified powertrains in the Embedded Academy e-learning? So this structure is always the same, and this you get for every course. So if you are interested in a certain topic, you can dive into the topic and read what it's about. Yeah. So this is the overall navigation. It's always e-learning portfolio here to get to the portfolio and then to go into the courses. And if you see you have a wrong language, this is the language button, so you can switch between the languages. And if you don't want to scroll down because the Embedded Academy content is growing very fast, then you can choose, for example, only e-mobility or only like software topics, and then it's reduced. Okay, but I think this is now all I wanted to show. Yeah. So I'm getting back to you, and if there really are no questions, I wish you a very nice remaining day and a very wonderful weekend. We'll enjoy snow in Germany. I don't know how it's somewhere else. And thank you for joining. And you know that the recording will be also available in the future on YouTube. So we'll provide it for a longer period of time. Thank you.